All right, so we're live 52 weeks of AWS episode 17. And today I'm going to be talking about implementing elasticity, high availability, and monitoring. So we'll cover those core concepts inside of AWS today, continuing on this journey to get solutions architect certified. So let's go ahead and get right into it. I'm going to share my screen here and get right into the material. Here we go. So to start off with, this is always a fun topic, elasticity. To me, it really highlights what is the point of the cloud, right? The point of the cloud is to be able to withstand against certain loads, not have to pre-provision things. And that's really the idea here with elasticity. And so we'll talk about architectural needs, scaling compute resources, scaling databases, designing an environment that's highly available, and monitoring all the fun stuff for solutions architect, elasticity material. So by the end, you're going to be able to know about EC2 auto scaling, how to scale a database resource, how to also use an application load balancer to create a highly available environment, use Amazon Route 53 for a domain name system failover, create a highly available environment, design architectures that use CloudFront to monitor resources and react. Okay, let's get into potentially where this would fit into a high-level architectural need. I'm showing a diagram where there's a very complex ecosystem, and it's going to need to be made elastic. So how would we do this? Well, let's talk about some of this reactive architecture. In general, the principles of a reactive architecture are that it's elastic and scalable. So what this means is that you don't have people standing by waiting to provision machines. Your machines are in a configuration where they're able to withstand to a higher load. They're able to scale up to additional traffic. And this is a reactive system, right? So if you had potentially a Super Bowl commercial, you could potentially respond to all of that traffic in a timely fashion. Another thing is resilient. So if, for example, there's a region that fails or potentially a virtual machine goes down, those are the kind of things that are important to take care of to make sure that your application is able to work even if there are small outages. And this is really what a load balancer can do. It can check for the health of a particular virtual machine, notice that, it's got high CPU or it's not even available, and take it out of commission or launch another machine. So it's able to have some smarts about what to do. Responsiveness is another one. If you have co-located servers in only one part of the world and you have people in South America that are trying to access your website and they get very very high latency response, they may go away. And so you need to have the ability to scale up to different parts of the globe, also to cache your data. And then also message driven is really a core component of a reactive architecture. Instead of polling, constantly churning CPU, you actually can put a message in, let's say Amazon SQS, have a Lambda that attaches to it and serves out that traffic. So let's talk about scaling your compute resources. How would you actually go about doing this on the AWS platform? To start with, let's define what elasticity really means. It's the ability to expand and contract capacity as needed. So a few examples would be increasing the number of web servers when traffic spikes. That's a perfect example. Another one would be lowering the write capacity on a database when the traffic goes down. Handling day-to-day fluctuations of demand through architecture. These are all great examples of elasticity in practice. Another example would be seasonality, right? Where if there are holiday type changes where you're maybe a motel and you have a national chain, there's going to be certain times of the year we're going to get lots of traffic to your website for booking. And can you handle that traffic? Is the database in RDS, or is the load balancer in a configuration where it can expand and serve out more traffic? Okay, so next let's talk about scaling here. Scaling is a technique that's used to achieve elasticity, and in particular, a couple of examples of scaling would be either horizontal scaling or vertical scaling. In my opinion, most of the time you want to do horizontal scaling because in this particular situation, it's called scaling out, when you want to scale to add new virtual machines, and then scaling in allows you to decrease the load. And so it's really the ideal scenario for cloud computing, because you are using only what you need when you actually are deploying new services, and you don't have to actually pre-provision things. Now, vertical scaling can work as well, and there's some reasons why you would want to do vertical scaling. One of the limitations is that, unlike horizontal scaling, eventually you'll run out of a bigger machine. I've actually had this happen before in production environments on AWS, where I had an RDS server. It had some vertical scaling issues, and we were basically limited in that we now had to re-architect our system. It's better, before you get to that point where you can't scale anymore, to figure out a horizontal scaling strategy. That's really the dream scenario. So Amazon EC2 has auto scaling built in. You can launch or terminate instances based on conditions. You can register new instances when a load balancer is specified. And you can also launch things across availability zones. These are all great ways to utilize cloud computing. In terms of the scaling options, a couple things to consider are there are scheduled scaling out, there are dynamic scaling out, and there's predictive scaling out. So in the case of scheduled, this would be good for predicted workloads here. So for example, turning off your development and your test instances at night. Dynamic, this would be good for potentially scaling out based on CPU utilization, and predictive would be handling an increase for an e-commerce website during a major sales event. So you would scale based on machine learning. So these are all three great options, and you need to pick the right one for the job you have at hand. Dynamic scaling policy types, there's simple scaling. So in this case, you would just say there's a new workload, there's spiky loads, there's step scaling. So this would be adjusting based on the size of an alarm. So for example, the CPU gets over 75%. We need to go ahead and do some kind of scale action. Tracking scaling, this would be horizontally scalable applications such as a load balance application and batch data processing applications. Auto scale groups would be minimum capacity, maximum capacity, desired capacity. These would be good things to consider, because in the case of a min and max, it's important to consider what's the minimum load that is actually going to be able to serve out your traffic, not just the maximum. You need to have a capacity that's at least able to withstand regular traffic as well. Sometimes it's easy to only think about the maximum, but it's important to consider the minimum, which in some cases would be the desired capacity. Amazon EC2 auto scaling purchasing options, you can do on-demand instances or reserved instances, or you can do spot instances. These are all three different kinds of options. In particular, this is something you see a lot in AWS certification material, is that you have to make this choice. Do you want to use on-demand? Do you want to do reserved instances? Or do you want to use spot instances? And in fact, my opinion is most people that are initially are prototyping on AWS should be using spot instances. They're 90% off. Why would you pay all this money when you don't need it? If you're just prototyping something out, typically that's a good solution. Also for machine learning, you see spot instances are a huge factor in, let's say, doing Hadoop or Spark, or using SageMaker, or doing some kind of experimentation with AWS Batch. These are all great use cases for spot instances. Automatic scaling considerations. There's multiple types of automatic scaling. There's simple step or target tracking, multiple metrics. You don't have to just use CPU. You could do things like latency or memory. And it's important to know when to scale out and when to scale in. And you can also use lifecycle hooks. So in this case, if you wanted to go through and set up some auto scaling policies, this would be a good time to play around with that on your own. But in general, Elastic infrastructure expands and contracts. EC2 auto scaling allows you to set these policies. And when you configure an auto scaling group, you can specify the instance types and the pricing models that you use. So this is really important for batch-based jobs. Okay, let's talk about databases next here. Vertical scaling with RDS. This is the concept of push button scaling. So you can take a DB instance and vertically scale it up and down. I've done this many times. I've even done it, I hate to say, in production before, where I've had a massive spike and I've had to just do an emergency action where I had to scale up the database. Believe it or not, it works pretty well. They have micro to 24x large. You can scale vertically with minimal downtime. Horizontal scaling with RDS. You have read replicas, read and write, asynchronous replication, read only. You can horizontally scale for read heavy workloads. You can have up to 5 read replicas and up to 15 Aurora replicas. The replication is async as well, which is pretty nice, and is available for MySQL, Maria, PostgreSQL, and Oracle. So how would you scale with Amazon Aurora? Each Aurora DB cluster can have up to 15 Aurora replicas. Primary DB instance, you could have DB copies, you could have Aurora replica, you could have also DB copies. This would be maybe up to 15 different Aurora replicas. So Aurora really is the biggest type of clustered database in terms of a traditional SQL relational database that is offered. So if you do need scale, this would be the thing you would pick. So there also is Amazon Aurora Serverless, which is pretty cool because it will allow you to respond to scale, start up, scale down. You can pay for the number of capacity units that are used. It's good for intermittent and unpredictable workloads. Without shards, all data resides in one partition. With sharding, the data is split into large chunks. And in many circumstances, sharding improves the right importance, the right performance. So this would be another kind of horizontal scaling, right? Is you could, in addition to having the read replicas, you could also split this up into shards. You can scale with Amazon DynamoDB on demand as well. And so what's nice about this is it is serverless, and so you don't have to do provisioning. It's a use case for spiky, unpredictable workloads. And in particular, key value database workloads are really common in gaming or metrics. With DynamoDB, you can do auto scaling for new tables. So you can specify an upper bound, a lower bound. And this is really probably the use case for most applications is auto scaling. So how would you implement DynamoDB auto scaling? First step, create a scale policy. 2, consume capacity metrics are published to Cloudwatch. And then 3, that Cloudwatch would use SNS to send an email message. SNS is a great service for just sending like really quick messages to a fan out architecture. And then in Cloudwatch would then evoke an application auto scaling event. And then in step 5 here, the application auto scaling update table request would go to DynamoDB process request. So scaling through capacity, DynamoDB adaptive capacity enables you to read and write to hot partitions without throttling. You also can automatically increase your throughput capacity for partitions that receive more traffic, and it's enabled automatically for DynamoDB. So adaptive capacity example here would be, in this case, you have partition 1, partition 2, partition 3, partition 4. You have consumed 50 WCUs, and you have provisioned WCUs. And the idea is that you can spin up to this particular capacity depending on what partition is actually being consumed. And so adaptive capacity doesn't fix the hotkey and hot partition problem, though. So the bad of it is that, for example, if you have item creation date rounded to the nearest time period, or you have a device ID where many devices are tracked, but one is way popular, then you have the whole hotkey problem. So you have to be aware of that. So you can use push button scaling to do things for RDS DB. You can use read replicas, shards. There's Amazon Aurora, DynamoDB as on demand, and it also has auto scaling and adaptive capacity. So what about designing an environment that's highly available? What are some of the things to consider in designing that kind of an environment? Well, to start out with, we have thinking about some measure of degradation, but you're still available. We want to minimize the downtime. We don't want humans, if possible, to be involved, and we want to recover from failure or roll over to a secondary source. So the percentage of uptime here, we could have 90, 99%, 99.9, 99.99, 99.999. These are all different things of uptime. The equivalent in a 99.999% environment would be not even 1 second. It'd be 0.86 seconds. So it's important to consider what it means when you hear someone say 99.999. It really means they're almost never down. So elastic load balancing, this would be managing load balancing services that distribute incoming application traffic across EC2 instances, containers, IP addresses, Lambda functions. These can be external facing or also internal facing. Each load balancer would receive a DNS name, and it recognizes and responds to unhealthy instances. So this is really the bread and butter of doing things in terms of a load balanced environment. And the two types of load balancers to be aware of mostly would be application load balancer, and this is around HTTP and HTTPS traffic, so web-based traffic, and it operates at the request level of layer 7. In network load balancer, this is TCP, UDP, TLS. This is ultra high performance and static IP address for your application, and the load balancing for TCP, UDP, and TLS traffic. And this operates at the connection level of layer 4. The classic load balancer is another one that does come up, and especially for a certification exam, it may come up. And this was for doing HTTP, HTTPS, TCP, and SSL. So it's all combined, and it was load balancing across multiple EC2 instances, and it operated at the request level and the connection level. So it's important to know these three types of load balancers, although the two that are mostly used now are application and network load balancer. So how would you do this? If you wanted to implement highly available systems, you would start with 2 AZs or availability zones per region. And if a resource in one availability zone is unreachable, your application shouldn't fail. So that's really the core concept, is if an availability zone goes down, your application should still be able to work. So an example of a highly available architecture would be you would have ELB or elastic load balancing sitting across a couple of different availability zones. And potentially you could also have that even for private subnets and for the outbound traffic as well. Okay, so let's talk next here about Route 53. Route 53 is a highly available and scalable cloud-based DNS service. I personally use it quite a bit. I was a little bit of a DNS geek in my life. I've set up some DNS services myself. I've run DNS servers for years and years and years on Linux machines before the cloud was a big deal. And I've also set up very complex DNS servers in the past as well, where I would have something called split horizon, which is kind of cool, where you have the public DNS with subnets, and then you have private DNS with subnets, but they're all different. And what's cool is Amazon Route 53 supports all this stuff, and it's really sophisticated cloud-based DNS service. It will translate domain names into IP addresses. It connects user requests to infrastructure. It can be configured to route traffic to healthy endpoints, and it offers registration for domain names, and it has multiple routing options. So in terms of Amazon Route 53, we have a lot of different ways to route traffic. We have simple routing. We have weighted round robin routing. We have latency-based routing. We have geolocation routing. We have geo proximity routing. We have failover routing, multi-value answer routing. So there's a ton of different ways that you can route things on the Route 53 system. Multi-region high availability in DNS. You could use this to set up a multi-region availability, because Route 53 can do health checks on the load balancers in different regions. And so this would be a fairly sophisticated way to do highly available systems. We won't dive into Route 53 in person. I'll just talk about it verbally. Okay, so really the next thing to take away is monitoring. This is something I like to talk about a lot when I was an engineering manager, when I was an individual contributor, and also as a professor. I talk about this quite a bit, is that monitoring is data science for software engineering. So if you don't know what's happening with your software, you're not being data driven. That's the best way to think about it. And operational health, application performance, resource utilization, security auditing, these are all places where you need to have more data. And so what are the things to consider? Monitoring your costs. You can create a more flexible and elastic architecture. You should know where you're spending money. You can do cost explorer, budget, cost and usage report, a cost optimization monitor. All these things are ways that you could monitor what you're spending. You can have a Kibana dashboard. You could have Elastic Load Balancer. You could have Elasticsearch inside of this. This would be a great way to monitor your costs. Amazon Cloudwatch is really the core service that has a lot of subservices inside of it for monitoring. It can collect and track metrics. It helps you correlate, visualize, and analyze metrics. You can create alarms, detect anomalies, and you can also send notifications to make changes that you're monitoring. So really, in terms of, it's the central spot for anything to do with operations for cloud computing. So how does it respond? Metrics, logs, alarms, events, rules, targets. These are the core capabilities of Cloudwatch. In terms of metrics, the metric data is kept for 15 months. That's the typical way to look at it. And by default, many of the AWS services already give you Cloudwatch metrics like EC2, EBS, RDS. These all are sending the data to the metric system. The logs themselves are something you can also monitor, which is really helpful. Like in a log file, you could look for errors, warnings, connections, etc. Put those into Cloudwatch, and then if you wanted to, you could persist those logs, for example, to S3. But it is a great centralized place to search for log data as well. In terms of alarms, you can do things like set an alarm if the CPU is over a certain amount, like 80%, 60%, etc. So the alarm could say, if the CPU on this virtual machine is greater than 50% for 5 minutes, then I want you to trigger an action. I want you maybe to spin up another machine, but I also want you to send a notification to operations so they can look and make sure that everything is normal. Maybe you want to have both the human and the automation associated with that alarm. In terms of events, you can do things like make a change inside of an AWS resource and trigger some event. It used to be called CloudWatch Events, but it's now called Eventbridge. I've used this for building serverless data engineering pipelines. So for example, if I have a Lambda and I want to scrape a website, I could set up this Eventbridge to trigger that Lambda, go through and scrape a website. And that's a great way to do event-driven development and not have to waste resources by having something running constantly. You can also do rules as well. And so in this case, you can set up routing rules to determine where to send your data to build applications in real time. So a rule would match, let's say, an incoming event and route them to a target for processing. And a single rule can route to multiple targets. And so in this particular example here, a target could be an EC2 instance, it could be a Lambda function, it could be Kinesis, it could be whatever it is you want to send something to. So how does Cloudwatch and Eventbridge work? Well, what's nice about Cloudwatch and Eventbridge is that they are the kind of together, they make a comprehensive system where they have both the metrics and you can have rules that match those incoming events, and then configure things like an alarm to stop, start, or terminate an EC2 instance when a certain criteria is actually met. So in a nutshell, AWS Cloud Cost Explorer, budgets, cost optimization, all that stuff is part of your AWS infrastructure. CloudWatch is where you would monitor operational data in the form of logs, metrics, events, and it will visualize data by automating dashboards so you can get a unified view of your AWS resources, applications, and services. Eventbridge is a serverless event bus service that connects your applications with data from various sources. So really, that's it for what I wanted to cover for today in terms of a wrap up. I think the big things to be aware of are EC2 auto scaling, how to scale your database resources, right? Horizontal versus vertical. Application load balancers are typically the ones you want to use for web. Route 53 is for DNS failover. And it's important to think about creating a highly available environment. This is what the CTO of Amazon talks about when they say design for failure, and also design architectures that use CloudWatch to monitor resources and react accordingly. So really, in a nutshell here, I'm done for today in terms of what I wanted to cover. And I'll just kind of wrap up and say that the next topic that I believe I will be covering will be the automating your infrastructure. So automating your infrastructure will be next. and I will definitely cover that in 2 weeks from now. I won't be here next week, but thanks again for listening to 52 weeks of AWS, and I'll see you again in the future.